Linear functions review. So this is the review. You have this sheet, you have all the answers on it, and all I'm going to do is just show you how to work through and hopefully get those answers. So a ladder is placed against a wall, and the slope of the ladder is 7. That would be the rise over 2, which is the run. The run. The base of the ladder is 1.8 feet from the wall. Determine how high up the wall the ladder will reach. Determine the length of the ladder rounded to the nearest tenth. Alright, so let's draw a picture of this. Here's the ground, here's the wall, here's the ladder. The ground and the wall will make a 90-degree angle. The slope is up 7 and right 2. And this distance here is 1.8 feet. And we want to figure out this distance here. So let's call that h. Right, so what do we know? We know that for every 7 feet we go up, we'll go 2 feet over. If the base were 2 feet away, then we know that we would reach 7 feet up, but that's not the case here. So what we've got is rise over run is going to be equal to the rise over the run. Right? In other words, this slope is 7 over 2. This is something over 1.8, which is going to be equal to 7 over 2. And I think I'm going to need a calculator here. So cross multiplying, we get 2h is equal to 7 times 1.8. And so h is equal to 7 times 1.8 over 2. H is equal to, and I'm going to pause and grab a calculator. Okay, so got a calculator. 7 times 1.8 divided by 2 is 6.3. So the ladder, so that's part A. Let's do this here. A, the ladder reaches 6.3 feet up the wall. B, determine the length of the ladder. So what we now have to figure out is, now that we know this is 6.3, we need this. We're going to use Pythagorean theorem. So let's say let's do it this way. C squared is a squared plus b squared. So we've got the formula. C is the square root of all of that. And we are looking for the hypotenuse, and so we've got 1.8 squared plus 6.3 squared, the square root of that, rounded to the nearest tenth, and I guess this should also be, well, I think that was exactly 6.3. Yeah, it was. Okay, so we've got the square root of the 6.3, so I'm just going to pull that in as second function answer, plus 1.8 squared, enter. 6.55, 20989. Now remember the other way to do this, just, might as well give some hints. If we go to mode, down to float, and over to 1, then we're telling the calculator that we would like it to round to 1 decimal. So if I redo the calculation, if I redo the calculation, I'm going to have to actually go back and replace the A and S with 6.3. Delete 6.3. The only reason I got that before, plus 1.8 squared, and there we go, 6.6, right? So now it's rounding. So 6.6, the length of the ladder. Is 6.6 feet. 1 is done. 1 down. 7 to go. Determine the value of k if k over 20 and 5/3 represent the slopes of parallel lines. Well, we know that the slopes of parallel lines are equal. We're going to cross multiply. So 3k is equal to 20 times 5, 100. So k is 100 over 3. And we're just going to leave it like that. So unless it says rounded to the nearest, then leave slopes as reduced fractions, and 103 have nothing in common, so there's nothing to reduce. What if they represent slopes of perpendicular lines? So the slope of a perpendicular line will be the negative reciprocal of the known slope, which is 5/3. So we know that this slope, k over 20, has to be equal to negative 3/5. So I'm going to put the negative up top, right? I can write it here or here. This way I get 5k, cross multiplying, equals negative 60. So k is negative 12. And that's number 2. Is triangle ABC a right triangle if it has vertices here, here, and here? Justify your answer. So the first thing to do is let's draw a sketch, and this is just a rough sketch. Just put stuff in about the right place. So negative 5, negative 7. So there's point A. 5, 7. Well, this will be exactly kind of opposite, right? 5, 7. So there's B, and C is at negative 7, 5. There's C. So here's kind of a rough sketch of what our triangle looks like. So if this is a right triangle, I'm thinking, right, I'm speculating that angle C is the right angle. Now to do that, what I'm going to do is work out the slope of AC and the slope of BC. And if they are negative reciprocals, that is if they multiply to negative 1, then I know that the lines are perpendicular, which means that I know that this is a right angle. Okay, and that's what we're going to have to say. So slope AC is equal to slope formula, y2. We always use formulas, x2 minus x1. The slope of AC is equal to, so AC, we're using these two guys here. So 5 minus negative 7, which is 5 plus 7, over negative 7 minus negative 5, which is negative 7 plus 5. And that's 12 over negative 2. So let's call that negative 6 over 1. So that's the slope of AC. So we want this slope to be positive 1/6, but we have to work it out. We need to show that. So slope of BC, y2 minus y1, x2 minus x1. So we've got, in this case we're using these two guys, so 5 minus 7 over negative 7 minus 5. So that's negative 2 over negative 12, which is positive 1/6. So, and that's the slope of BC. So since these are negative reciprocals, we know that we have, but it says justify your answer, so you have to say something. You can't just leave it and say, yeah, hey, look, they are. So we're going to say, since the slopes of two sides of the triangle are negative reciprocals, then those two sides are perpendicular. Perpendicular. Right, so we could say that AC is perpendicular to BC. This means angle C is a right angle. And triangle ABC is a right triangle. Now, if you're doing this problem, maybe your sketch wasn't good. Maybe it's one of these other angles, which is the 90. So you would have to work out another slope and then see. There's only 3 slopes to work out here. And if these two were not negative reciprocals, I would work out the third slope and see if any pair of them were. And if not, then you would say it is not a right triangle because none of the slopes are, no pair of slopes are negative reciprocals. So there's no perpendicular lines. Number 4, for the points A, 5, etc. Determine the slope of line segment. This means line segment because there's no little arrows. Otherwise, we'd want line AB. So part A, the slope of AB is formula y2 minus y1 over x2 minus x1. And you choose. So we're going to go with 4 minus negative 2, which is 4 plus 2, over 15 minus 5, which is 6 over 10, which reduces to 3/5. So the slope of AB, m, remember little m is slope, AB is equal to 3/5. State the coordinates of another point C that is in the line AB. Well, so to get to any other point, what I need to do is just starting at, let's say starting at A, so that's 5, negative 2, which is A. This says go up 3 and go right 5. So if I go up 3, I'll be at positive 1, and right 5, I'll be at 10. And from there, I can do the same thing again. Go up 3 and right 5, so 15, 4. But I can also think of a positive slope as a negative, so I can go down 3 and left 5. So if I go down 3, I'll be at negative 5. And if I go left 5, I'll be at 0. So there's 0, negative 5, and we could do that again. Go left 5 and go down 3. And we could do this again. Go up 3, right 5. Just make sure your writing order pairs, they need to be in parentheses with a comma in between the numbers. C, state the slope of a line parallel to AB and state the slope of a line perpendicular. So the slope parallel, slope of a parallel line, so I'm going to abbreviate that. So M parallel, right, is the same slope, which is 3 over 5, and the slope of a perpendicular line or M perpendicular is the negative reciprocal, so negative 5/3. D, determine the equation of line AB in general form. All right, so we have 2 points. In order to do that, we're going to use the point slope form. We need the slope. We've worked that out. We're going to use the formula for point slope form. So D, that formula is y minus y1 is equal to m, x minus x1. We're going to substitute in, so we'll use point A. So this will be y minus negative 2, so y plus 2, is equal to 3/5 x minus 5. Now we need this in general form, and general form is ax plus by plus c is equal to 0. So we need to expand this out. So y plus 2 is equal to 3/5 x minus 3. 3/5 times 5 is 3. Move the 2 over, so we're actually going to end up in slope-intercept form first. So 3/5 x minus 5. General form, we need to get rid of the 5, so we're going to multiply through by 5. 5y is equal to 3x minus 25. And general form, we need this over here, so it'll be 3x minus 5y minus 25 is equal to 0. If that's the correct equation, we know that it will work for any of these points we figured out in B. So if you tried 0, negative 5, put an x value of 0 in there, then you'll see this has to be negative 5 in order to solve that or satisfy the equation. E, what's E? Determine the value of x if A, B, and D are collinear and D is the point x, comma, 24. All right, well, we know if they're collinear, A, B, and D, then they're going to have the same slope. So if we do the slope from A to D, so slope from A to D is equal to y2 minus y1, x2 minus x1. We know the slope has to be 3/5. We have some y values, so if we're going from A to D, we're going to go 24 minus negative 2, which is 24 plus 2. And from A to D using the x values, it's going to be x minus 5. So on the bottom, x minus 5. So 3 over 5 is equal to 26 over x minus 5. We're going to cross multiply. 3 times x minus 5 is equal to 5 times 26. 3x minus 15 is equal to 130. 3x is equal to 145. And x is 145 over 3. And I can ask myself, does that reduce? Or I can ask the calculator. 145 divided by 3, math, enter. So what this says is take 145 divided by 3, convert it to a fraction. And it is 145 over 3, so that's in lowest terms. There's no reduction. And we are done with number 4. 5, convert each of the following into general form. So we're simply going to expand this, 3x minus 21. So y is equal to 3x minus 23. Usually the journey to general form passes through slope-intercept. 3x, it's positive. Remember, your a value has to be positive. Minus y minus 23 is equal to 0, and that's your general form. Here, this is slope-intercept form. We're going to get rid of this 4. 4y is equal to negative x plus, that's not a 7 now, that's a 28. This needs to be positive, so we're going to move that over. X plus 4y minus 28 equals 0. And that's general form for 5b. And C, we need to get rid of this again, so we're going to have to multiply through by the lowest common multiple, which is 10. So 10y is equal to, 5 goes into 10 twice, so this will be 6x plus 1. 6x minus 10y plus 1, since the x is positive, we're just going to move this over, is equal to 0, and that's 5c. 6, sketch the graph of each line and label each line with its letter. We get to use colors here. So A, y is negative 4/3 x plus 6. So we start by finding the y-intercept. The slope is negative 4/3 or 4 over negative 3. So this says rise, go down 4, right 3. So let's do that, down 4, right 3, down 4, right 3, down 4, right 3. And I can also go up 4 and left 3, except I can't do that. So we have our point. Okay, so let's draw the line. I'm going to set my magic line tool, and I think I have one that has double arrows. Well, at the least it's got a single arrow. I'm going to end up with 2 different lines here, or maybe 3 if I draw that way. But okay, so that's kind of the line. Let's go back to the pen, and let's do this one in red. So y plus 2 is 3x minus 7. You can't really do too much with this, so let's put it into slope-intercept form. So y is equal to 3x minus 23, which is Wow, you can't do much with that anyways, because I don't have a minus 23 there, right? Oh, and I was supposed to label this as A, so let's label that as A. And it should have been in purple. Let's highlight over it in purple. See if I can trace a line. And arrows on both ends, so let me make big arrows. There, okay? Don't forget the arrows. All right, so this is a little inconvenient using, but I've got the slope. Can I get the x-intercept if I set, no, that's not going to give me any nice value here, so I don't really have any terrifically nice values. So let's see if we can work something out. What if x is 7? Okay, so here, let me go back to red. So if x is 7, 7 minus 7 is 0. This works out to 0, and y will be negative 2. So I've got the point 7, negative 2. So, sometimes we have to work our way around this and figure out a way to get a point. Now, I know the slope is 3, so I can just go 1, 2, 3 up, 1 over. And a slope of 3 also says go down 3, left 1, down 3, left 1. And now I want to draw that line. So I'm going to go to line. This will give me a double-headed dashed line. Let's see what that looks like. In green. Wow. Can I make that red? I think I can get, whoa. Whoops. All right, hang on. Let's Control Z out of that. Go back to the pen. Go to red. Okay, need an arrow. And an arrow down here as well. So if you remember this from now on forever and ever, whenever you're drawing lines, then you're going to be a lot better off. C, yellow, y equals negative 2x. Well, it's negative 2x plus 0, so we have a y-intercept of 0. Negative 2 says go down 2, right 1. Remember, a negative slope goes down to the right, down 2, right 1, down 2, right 1, down 2, right 1, or up to left, up to the left, up to the left, up to the left. And I'm going to freehand this one, which apparently was a mistake. Okay, I'm going to not freehand this one. We'll go draw a line. And what kind of a line do I want? Actually, I think I could choose stuff here. Line styles. Where's... there's no double-headed arrow. So that's kind of sucky. But here's what we'll do. We'll drop this here, and then we'll draw another line going this way. And there we go. And you know what? We'll go back to a yellow pen, and then I'll just sort of trace over this in yellow. Well, apparently I can't trace. Okay, and make the arrows obvious. And that is the line y equals negative 2x. Okay, what's next? Green. And y equals negative 4. Y equals negative 4 is a horizontal line. And so I'm just going to draw that in and put the arrows in and label that D. And now E, 5x minus 2y plus 6 equals 0. Convert to slope-intercept form. Best advice ever, right? I mean, how else can we do this? All right, so slope-intercept. I'm going to move this over, and then I'm going to reverse sides. So this becomes positive 2y, and that's equal to 5x plus 6. So y is equal to 5 halves x plus 3. And what color do we have? Blue. And let's move back up. So 5 halves x. Go up 5, right 2. Or go down 5, left 2. I should say or. I said and go down 5, left 2. Right? And do that a couple of times. And then we're going to pull out the line tool. So we go like this, and there we go, almost. Let's go back to the pointer. I need to move this end a little. I don't know if I can rotate the line. There. Boom. Done. And then let's go over that in blue. Let's at least put blue arrows on. And draw. And that is E. Okay, so there's all your lines. 7. For x minus 3y plus 9 equals 0, algebraically determine the x and y intercepts. All right, let's go back, and I like my thin line. So A, the x-intercept, you set y equal to 0. Gives me x minus 3 times 0 plus 9 equals 0. X plus 9 equals 0. X is negative 9. And the y-intercept, you set x equal to 0. So 0 minus 3y plus 9 equals 0. Negative 3y equals negative 9, and y is equal to 3. Graph the line using the intercept. So the y value is 3. The x value is negative 9. Now for sure I want my straight line tool here. I don't even know what that one's going to do. And basically I just kind of need to go through, and I'll do the same thing going the other way and just line those up. And I have my double-headed, I have my line. Your line needs to extend the entire graph. Okay, you can't just draw the line from here to here. That's not good enough for me. Draw the line, it goes through, it had arrows going in both directions. Convert the equation to slope y-intercept form. So we need to go back to a pen, and I have to keep changing my line style. So x minus 3y plus 9 equals 0. I need a positive y, so that's positive 3y, and that just leaves the x plus 9, right? And so y is equal to 1/3 x plus 3, right? Divide both sides by 3. 1/3. Not a very nice 3. Let's clean that up. 1/3 x plus 3. Right, a positive slope of 1/3 says go up 1, 1, 2, 3, over 3. Go up 1, 1, 2, 3, over 3. Go up 1, 3. And you notice how we just hit that intercept there. So, what's next? Number 8. Last one. This is longish, but you shouldn't even be watching this probably. Determine, which means show your work, okay? Don't just do stuff and expect, oh, I'm going to get full marks because I got an answer. Determine, show your work, the equation of each line in the indicated forms. So, line A in slope y-intercept form and general form. All right, so we have 2 points indicated on here. That allows us to get the slope by counting 1, 2, 3, 4. Down 4, 1, 2, 3, 4, 5, 6. So A, slope is negative 4, down 4 over 6, which is negative 2/3. The intercept is 6. The equation is y is equal to negative 2/3 x plus 6. That's in slope y-intercept form. General form, multiply through 3y is negative 2x plus 18. Move everything over. We need the x to be positive, so it's going over here. 2x plus 3y minus 18 equals 0. And that is the general form equation. B, slope point form and general form. It really doesn't matter what equation you're working out, you need the slope. And again, we have 2 points indicated, so we can count. Well, I'm not going to count in the calculator. So from negative 3 to 5 is up 8. And then from 4 to 10 is over 6. So for b, the slope is 8 over 6, which is 4 over 3. There's a point on b, and I'm going to use the 10, 5. Now if I do anything, it's formula, right? So the formula for point slope form is this. We got the slope by counting. We're going to use the point, which is 10, 5. And so we are going to write y minus 5 is 4/3 x minus 10. So that's one alternative. The other alternative would be to use this point, which would give you y plus 3 is 4/3 x minus 4. This is the point 4, negative 3. So when you do y minus y1, it's going to become y plus 3 x minus 4. That is another form of that line. Both of these are the same, and you can't really see that easily, right? Which is why we usually go to a different form, because general form or slope-intercept form will be the same. So to get either of these, let's just work with this one. So I'm going to multiply everything by 3. 3y minus 15 is equal to 4 times x minus 10. Okay, we're not going to expand this. I don't need all these thirds hanging around. I'm going to get rid of the thirds by multiplying by 3. 3y minus 15 is equal to 4x minus 40. General form, I need a positive x, so we've got 4x, move it over, minus 3y, add 15, minus 25 is equal to 0. And what if you had used this one? So you'd multiply through by 3. 3y plus 9 is equal to 4 times x minus 4. 3y plus 9 is equal to 4x minus 16. The x is positive. 4x, bring the 3, minus 3y, the 9, minus 25 is equal to 0. And these guys are the same, right? So slope point form is usually just a way station on the way. It's on the way to converting to a different form, slope-intercept or general form, which will always be the same. C in general form. Well, that's pretty easy, right? This is just the line x equals negative 5. So that becomes x plus 5 equals 0. And that is all the work required. That's determine, right? Which is show your work. So this is what I'm starting with, and this is what I'm doing. So for any of these guys, if you somehow magically, right, you have to show work. So you got to show this is where I got the slope, and then here's the slope-intercept form, right? And then here's me working it into general form, and then here's me going into general form. They don't just spring forth, right? Nobody looks at line A and says 2x plus 3y minus 18 equals 0. So you don't get to do that. And that's that for that, right? So, if you've stuck around and watched this for the last half hour, good on you, and hopefully that will help you out for the test, which, if you're watching this, is probably coming up pretty soon.